So let's look at this worksheet. So a car is traveling. Oops, sorry. A car is traveling along a straight, non-curved section of a highway. What does that mean? What's if you're traveling on a non-curved straight section on a highway? What is the only thing about the car's motion that definitely does not change? Direction. Thank you. So that means what we already, because again, remember, we said that in this course, no turning, only in grade 12. So here we already what imposed or we fixed the direction. So apparently the car is like 3 snapshots. This is one snapshot. This is another snapshot. This is another yet final snapshot. The first 2 snapshots are separated by 20 minutes, and the last 2 snapshots are separated by 45 minutes. Okay, and the speeds technically they are velocities, but we can call them speed. However, if I want to call them velocities, what should I add to the diagram? Remember, what's the difference between velocity and speed? Velocity is a what? Vector, which means it needs a what? Are any directions given here? So does that mean you can do any direction you want? Absolutely. Remember, unless I choose my direction, you're stuck. Here, you can choose any direction you want. You can make it the usual, I guess, west and east. You can flip. You can make it north and west. Sorry, it has to be opposite. North and south, south and north. You can make it this way, that way, forward, or it doesn't matter, okay? Just to be consistent with the worksheet solution I'm going to post, I chose the direction here to be, I believe, north. So everyone, just put capital N here. Go ahead. Hey, capital N here and capital S here. So by doing that, the car is always traveling which way? North, 100%. Okay. Question number 1. Does the motion of the car represent uniform motion? Yes or no? Explain. How many people say yes? This is an example of, remember, you never just say yes or no, my course. You have got to defend your answer. How many people say yes? How many people say no? Hannah, why no? Why does this fail, in your opinion, to be a uniform motion? So remind me again, what are the only 2 conditions from your slideshow on Friday? What are the only 2 conditions for an object to maintain, to exhibit uniform motion? It has to maintain what and what? The same direction, not a problem, and the same magnitude of the vector. Exactly, speed. Done. It fails 1. So the easiest answer is no, because the speed changes. Done. Which really means the velocity as a vector changes. So we're going to say no, because the speed is, we can say what? Not constant, slash fixed, slash uniform, whatever. Slash fixed. Either word is 100% correct. Done. That's it. That's the easy explanation. It fails, as Hannah said, 1 condition of the 2. Done. Obviously, if it was turning, it's even worse because it would fail 2. Okay. Does it exhibit uniform acceleration? That we don't know. That we have to do what for? We have to actually perform some calculation. We cannot just guess and say, you know what, it kind of looks like it. There's no kind of looks like in physics or math. Okay? We are physics people. We go by what the math tells us, and that's it. So for each time interval, for each time range, determine the acceleration. Obviously, technically, instantaneous or average. Of course. So even if I don't say average, you already know, especially if you have a time interval, I am talking about acceleration. In what unit? Kilometers per hour squared. Okay, there's a problem here. Look at the diagram. How come the diagram is not consistent with the units that I am asking for you to do? What is the time scale of the diagram? Minutes. So I have to convert what? Minutes into hours. How do you convert any number of minutes to hours? Again? How do you convert minutes to hours? How many minutes and so how many minutes an hour? So my question is, if you're going minutes to hours, are you going to multiply by 60 or divide by 60? Divide by 60. How do you always know that? Have a quick, everyone, always have a quick short example in your head. 60 minutes is how many hours? How did you do that? Did you multiply by 60 or divide by 60? If you multiply by 60, you get 3,600, which is how many seconds in it. But if you divide by 60, you get what? So always have a quick, by the way, especially when you teach younger kids, that's how you always do it. Just have a logical short example that you can always go back to whenever you want to see, should I multiply or divide, and that kind of stuff. Okay, so obviously I have to what? Do we have an equation we can use to find average acceleration? Did we learn an equation on Friday to use for average acceleration? Yes, we did. What was the equation? What was the top part of the equation? The fraction. Change in speed, not change in, yeah, again, acceleration is a vector. So technically, even though we fix the direction, we have to say velocity. So final velocity minus what? Over. Exactly. Technically, it's time final minus time initial. But do you already know the time size? Yes, you do. I will never bother you with f and I with time. I will give you the delta t. All right. So let's start. So we just have to write the equation. So go ahead. A average equals, as you said, VF subtract VI divided by what? Change in time or delta t equals. All right. What is my final velocity of the first interval of time? Just the first interval. What did the car get to? No, but what? So what was the car's velocity at the end of the 20 minutes? Yes, 87. So by the way, how many digits does it have? By the way, look at all the numbers in the problem. They all have what? 3 digits. Okay. So 87 kilometers per hour. In which direction? Thank you. Subtract. What was the initial velocity value? 75 kilometers per hour. Also in the north. Divided by how much? K. Now, how much time has passed by? Well, no. The first time. The first interval. 20 minutes. But I need to convert it to what? Hours. We said we're going to do what? We're going to divide by 60. Okay. Question. Hold on, everyone. What's 20 divided by 60? Now, perfect. Now it depends. If you're going to do it this way, 20 divided by 60, what do you think you're going to get? An infinite number of threes, right? Because it's what? It's an infinite decimal. Technically, how many are we keeping for a final answer? 3. So how many should you always keep for intermediate step? At least what? One. By the way, for intermediate steps, at least go how much more? One more number to what? To maintain that at least if something goes wrong, your what? Your final precision does not get what? Does not get affected. However, is this infinite decimal a perfect representation of a perfect fraction? Actually, yeah. Come on, 0.3333 forever is really what as an exact fraction? 1/3. Do you see what I mean? So you choose what to do here. You can put a bunch of 0.3s here in hours, or you can just put what? 1/3 of an hour if you want to keep everything what? Exact and not approximate. Do you see what I mean? So it's going to be up to you. So you know what? Let's go exact for today. So 1/3. So go ahead. 20. I want you to write this. 20 divided by 60. In what unit, as we said? In what? Hours. No. The bottom part. Okay. Let's clean up. Equals here. What's 87? By the way, are the directions okay, or does one of them need to be flipped? Seem to be okay. So you commence with the math. What's 87 divided by 75? Sorry, subtract. Subtract. 87 take away 75. 12. So 12.0 kilometers per hour. In which direction still? In the north. Divided by 1/3 hours. What do you think we mean when you divide by a 1/3? By the way, whenever you divide by, okay, you're saying what? You're saying cross multiply, but remember, cross multiplying only happens with what? When you have two fractions equal to each other and you're trying to solve a part of one of the fractions, right? Like an x. Are we trying to solve here or just find a value? Like, evaluate. What does it mean to divide by a fraction? You meant what? Exactly. She did this, but she actually meant what? Flip. However, everyone, here's an easy way. If you divide by a third, that means you're multiplying by what? 3. If you divide by a fourth, multiply by what? If you divide by 1/11, that means you multiply by what? That's the effect of the what? Of the double division or the flip. So really, all we have to do is what? Multiply 12 by what? By 3, not by 1/3, by 3. What happens to the hours? Do they cancel out? Do the hours cancel out from the unit analysis? Why not? Tell me why. I gave you an explanation on Friday. Why can we not cancel the hours? Sally? Hold on. So my question to you is, if you cancel the hours, what only remains? Can you measure acceleration in just pure kilometers? What can you only measure as using kilometers? Things like what? Distance, displacement, position. What technically, not technically, legit is the unit for acceleration? Kilometers per hour. So even though it might look like it cancels, we know it what? It doesn't because of the double division. So don't even bother showing me any unit work. Just what? Just write the unit at the end. Can someone tell me what's 12 times 3? 36. Technically, we need to put what? 36.0 because we have to maintain it to 3 sig fig. So 36.0 in what unit? You do have to guess. Exact. Square. I will always remind you. Kilometers per hour squared. In which direction? All right. Ladies and gentlemen, I want you to do on your own, as a group if you want, the second part. Go. So I'm just going to start it off. I'm not going to do anything. I'm just going to be ready. So I guess my 2014. Okay. You have a number, just raise your hand. Yes. Again, does the car ever flip and travel physically south? So that means what? The speed, sorry, the velocity is the same as the displacement. It's also north. You see what I mean? Again, remember, displacement tells you, look, Yasmin, displacement tells you which part of the, which way of the universe you're going. Which way are you going? It's getting more and more and more north, which means velocity is also what? More and more and more north. That's why. Yep. By the way, velocity and displacement always have the same direction. Because velocity just tells you how fast you're going in already a direction that you know. Okay, always. Yes. Nice. Okay, one more minute. Okay, all right. So how many people are getting 36 as well? Does that make sense? What does that tell you about the car? Is it uniform acceleration? Hold on. Did we get the same value of acceleration for both times? Sorry, for both time intervals. What's the definition of uniform acceleration? Two things. You maintain the same what? Which we already discussed that it is true. But you keep the same what? No, no, hold on. If listen, no, good. These are the true false questions and the conceptual one. If you keep the same velocity, what does that mean? You are uniform what? Motion, cruise controlling. But you're not keeping the same velocity because it's changing, but you're keeping the same what? Accelerate. You're keeping the same speed gain the whole time. Okay, here's a question for you. Everyone, don't do this. I'll do it right now. Everyone, check this out. What if I did, everyone, pencils down. What if he did not look at the 20 or the what? What if you looked at the whole thing? Okay, can you still do that? Can you assume that this cut was not here and you just got to go from here to here? Can you do that as well? Yeah, you can. Okay, what? No, I'm with you. But what if I did not care about them in what? In two distinct intervals. What if I looked at the whole thing? What if I did not know that after 20 minutes they built up to what? 87. What if all I knew was what? They started how much? 75. They ended at much? How much? 114. But how long did the whole process take now? 20 plus 45, which is what? That's fine. Okay, so let me actually do it for you to prove to you what we're doing here. So what's my final velocity now? 114. Let's not worry about units or direction. We know they are the same. What's my very first speed? Come on. 75. What's my time? What do I do? 65 divided by 60. Yeah, that's going to be 1 and 1/12, which is which is going to be a lot of decimals. Do you think you can simplify this as a fraction? Come on, people. What is a common number between 65 and 60? What do all numbers that end up in 5 or 0 divide? 5. Thank you. So technically, this is equal to what? 13 over? No. If you divide 65 by 5, you get 13. You divide 60 by 5, you get 12. Okay. Can someone tell me what is this? What's 114 plus 75? It's 25 plus how much? No, sorry. Okay. If you're always asking me, how are you so quick with the mental math? This is what I do. How much does it take me to go from 75 to 114? Okay. How much does it take me to go from 75 to 100? 25. And then I have to add another what? 14. What's 25 plus 14? 39. Done. That's how you do it. You always cut things up. So it's 39 divided by what? How am I going to do this division? No problem. Put this over what? Nice. So 39 over 1 times what, though? Do you really think I'm going to multiply 39 times 12 in my head? No. I'm going to do what with these two? Simplify, because they can always what switch the location to make them the friendly ones go together. What's 39 divided by 13? How many 13s in 39? 3. This divides by 13 gives you 3. This divides by 6 gives you 1. Guess what? 36. What does that mean? Whether you're looking at the first 20 minutes, at the last 45 minutes, or the whole thing, was it the same press on the gas the whole time? There you go. Is it making sense now? So what do you conclude about uniform acceleration? Does it matter where do you look? Does it matter which interval you look at? No. You could look at the first minute. You could look at the what? Last minute. You could look at 10 minutes in between. You could look at 15 minutes at the end. You could look at 7 minutes at the beginning. Do you see what I mean? It's the same behavior of the whole time. Yes. Okay, let me just finish this one. Do not change it. I'll come and check it after. Okay, so what do we have here? We said we're going to get how much? How about this one, though? What's the difference between 114 and 87? 13 plus 14 is how much? 27 kilometers per hour in the north direction, divided by how much is 45 divided by 60 as an exact fraction? 75% or 3/4. So 3/4 of an hour. Okay, which means 27 times 4 over 3. It's exactly 36 all over again. So 36. No. Yeah. Or by the way, question for you. Question for you. Was 20 divided by 60 a good number decimal wise? 20 divided by 60. Was it good decimal wise? No. It was what? 0.3333 forever. How about 45 divided by 60? Is it a good number decimal wise? It is. How much? 0.75 with nothing else. So feel free then to use the decimal part instead of the fraction. So what is this one? 36 kilometers per hour in the north direction. So does the motion of the car represent uniform acceleration? Yes. Why? Because acceleration was kept the same the whole time. So yes. This one is a yes because acceleration was constant or fixed, constant / fixed all the time. All the time. Done. Okay. Last question. Okay. Walid, 2 ways. I could divide 27 divided by how much? 3/4, right? But what's 3/4 as a good decimal? Ali? 0.75. Check this out. 27 divided by 0.75. Okay, again, I might sometimes show you fractions because I want you people to be comfortable with fractions from now on. All right. Last question. Assuming the car keeps what? Keeps what? Speeding up or accelerating. For only how much time though? Only 30 minutes. What is the speed in kilometers per hour? Should that be hour squared or hour? Did I make a typo here or is this correct? Typo. How many people say it's a typo? Ibrahim, why is it a typo? That's why I love. I don't just ask you, I ask you, why do you think it is? How many people think it's a typo? This, this. That this should be a square. So is it correct to be just kilometers per hour? Yes, I'm with you, 100%. That's my point. We've been doing kilometers per hour squared for a while, so I'm playing reverse psychology on you. Because now everything in your mind is what? Kilometers per hour what? But you need to know, when is it kilometers, when is it kilometers per hour, and when is it what? Every one of them means something totally different. So this is correct. And by the way, what word am I using here? Come on. Speed is in kilometers per hour or meters per second. 30 minutes after it reached a speed of 114 kilometers per hour. Okay. Am I asking you now for acceleration? Or am I asking you for final speed? But what did I say about the acceleration? So is the A still 36 kilometers per hour squared? Yes, you're keeping the same the same press on the gas as the first 65 minutes. Can I still use the same equation? Okay, hold on. Thank you. Okay, do I have this number now? Do I have this number? Do I have this number? Yes, it's the 114. Do I have this number? Whenever your number that you're trying to find is on the which side of the equation? Right side, most likely you have to do some rearrangement. This is what we call algebra. Okay, well, you know what? Let's just write the equation first. So A, okay, question everyone. Do you think the car would still be moving north? Did it slow down and reverse or keep speeding up? So are all the directions in the problem the same? Initial velocity is north. Final velocity is north. And acceleration is also what? Do you remember what we did for a question last week when all the directions were the same? I skipped, exactly, thank you. I skipped all the directions in the question. But I'm just going to write them here, everyone. So I want you to write this. AAV is what? 36 kilometers per hour squared north. V initial, how much is V initial now? It's the final phase of the problem, which is how much? What's the V initial now? What am I starting from? 114, which used to be my very final F, but not anymore. 114 kilometers per hour north. What's my VF now? Do I know it or not? Question marks. What's my time? 30 minutes. But I need it in what? Hours. So 30 divided by 60 in hours, which is exactly what? 1 over 2, which is exactly how much in a decimal? 0.5, which is a perfect decimal, so we can just use the decimal. 0.5 of an hour. Okay, now let's use the equation. A equals VF minus VI over delta T. What am I missing from this equation? What am I missing on top of so many symbols? The arrow. But what did we just say? Are we going to ditch the directions? Yes, we will. Also, could we also ditch the units now? Are all the units good and similar? Yeah, all the distances are in kilometers and all the times are in hours. Perfect. Skip. But is it still technically hours? Do you see what I mean? All the time scales are in hours. Whether it's a square or not square, it's in hours. Yeah. By the way, again, we know that the math will work its way out to give me kilometers per hour at the end. Perfect. Okay. What goes here? 36. What goes here? Or just what? Keep calling it what? I mean, you could. No. Okay. By the way, you can call question mark on the list. Do you ever want to put question marks on an equation? No. But okay, I agree with you, X. But doesn't it already have its own symbol? Exactly. Keep it the same because then you don't have to translate it back into VF. So VF minus how much? 114 divided by 0.5. How do I solve something like this? Get rid of the what? Yeah. Is there a fraction here? Is there a fraction on the other side? Technically not. Exactly. Put your best friend 1. And now it's a what? What is it? Cross multiplication. So those two and those two. What's VF minus 114 times 1? Anything times 1 is the exact same thing, whether it's a variable or an expression. So VF minus 114 equals, what's half of 36? How do I solve that? Only one thing to do. Exactly. Move what the number to the other side. So VF is equal to what? 18 plus 114. How much? 130. What's the unit for this? It's a speed. It's a kilometers per hour. Yeah, go ahead. Oh, sorry. Before your question, 1 second. My question to you is this now, so far, is this a speed or a velocity? The way it looks like. No. The way it looks. Speed, because I did not put a what? A direction. Okay. Technically, what is the question asking me for? Is it asking me for the final velocity or final speed? There you go. By the way, most of the time, I'm going to ask you for scalars, not what? Not vectors. However, if you get asked for vector, you have got to write the last statement here. You have to say what? VF final equals what? 132 kilometers per hour, heading which way? But according to the question, we don't need it because the question officially asked for speed. Done. I know we did, but let's think about this for a second here. Velocity and speed are the same in one case if everything keeps going what? Same direction. Is it making sense? So technically here, every velocity, every value for velocity is also the velocity, the value for what? For speed. Oh, everyone, if it was different, if it was turning or reversing, sorry, things are different then. I'm just using a special case analysis. Okay, I always like to tell you shortcuts, but tell you when they work and when they don't. Sorry, Ali, you had a question. Yes. So, okay, so what does that mean? It's gaining 36 kilometers per hour for every single hour, which means, thank you, which perfectly, again, if you're gaining a fixed rate of $36 per hour and you only worked for half an hour, how much do you get? Half of that, which is 18. It's exactly the same. Now you're saying that's all you did, right? You just got it because, so you did it logically, like a grade 9 student, right? Perfect. I want you to get used to doing it what? The legit equation way. Make sense? Because we're gonna deal with tougher equations than this, so I'm just building up the scene. All right? And that's today's lesson. That's all I wanted to cover. Just now we know exactly how to calculate backward and forward average acceleration and uniform acceleration. That's it.